and head of engineering for RMSTATOR. This is Q&A. We have a question here. Somebody says, make sure I read it right. Okay, so I got a vehicle. It had a previous charging issue, and I was told to replace the stator. And I did that, and I'm still having charging issues. What is going on? Well, could be a couple things. So pretty common, stator gets pointed out a lot as the cause of failure for a charging issue. A lot of times it is, for good reason. They do fail. And it's certainly a good place to start. As you've probably seen in our other videos, we've talked about how to test a stator. I'm never a fan of just replacing parts, for the hell of it. Go do the test and try and find the problem and rule it out before you replace it. Don't just throw parts at something. So, you'll see used bikes for sale. People will say, oh yeah, it just needs a new stator. Well, may or may not. Could be lots of things. But always do your test. Replace the stator if necessary. If you're still not charging, then do your voltage regulator test. You should really be doing those at the same time. And it's always useful on an older vehicle to replace stator and regulator together. Why do them separately? They're both the same age. And then load test your battery and replace it if necessary. If you do all those things, you're going to have a good charging system. We've got a question today that is, how do I know if I need to replace my CDI box? So good question. You can't typically test a CDI box, right? It's an active component, has to be powered and provide a timing signal and blah, blah, blah. So there's nothing you can do with the multimeter to check. I have seen in some service manuals, especially for older vehicles, they'll provide like a resistance chart to show you various resistances between pin to pin on a CDI box. I don't know. I always kind of doubted that was ever accurate to begin with as a way to rule it out. But the old boxes, like from the early 90s, maybe were, not microprocessor controlled. So there was ways you could do a check that way. But with any modern box, and certainly any one we build, we use microprocessor control, and they're active components. There's just no way you're going to test it with a multimeter. So you can't test a CDI box. So what you do is you rule out everything else associated with it before you replace it. Okay. Let's start with the stator. If your stator has a pickup coil for a timing signal, you need to check its resistance and make sure it's working correctly. We also sell a peak volt adapter that will help you check the pulse coming out of it. You need to check your source coil if you have one on the stator. That's the coil that would power the CDI box. Check its resistance, and you can check the voltage coming out of it with a multimeter. Both of those have to be in good working shape. You can also pull the cover and make sure that your pickup coil looks good and it's a good space away from the trigger on the flywheel. So that's critical as well. Other things you should check is your kill switch. We've seen many times a kill switch could be shorted either at the handlebar or a wire broke. And CDI boxes can kill in various ways. They can ground a wire to kill. They could need a permanent ground and that wire opens up to kill. They could supply plus 12 volts from the battery to operate and then remove that 12 volts to kill. So there's lots of different ways to do it. Make sure you look at your diagram, your factory diagram for the vehicle to see how that works. So you need to make sure your kill switch is functioning correctly. You could always, with the type that grounds a wire to kill spark, you could always unplug the kill switch because that'll take it out of the loop and make sure it's not a problem. Next thing is your ignition coil. Make sure that the coil tests good. You can test the resistance of the primary and secondary of the coil. We put those specs on our website for our coils, or your service manual will have it, and make sure the coil's in good shape. Always check your spark plug wires, the spark plug caps, and the plugs themselves. So rule all that stuff out. If you have checked all of that, not to mention good battery voltage if you're running a DC or battery powered ignition, once you've ruled all that stuff out, and it can be safe to assume that the CDI box is bad. But please do all that stuff first. Don't just blindly replace a CDI without knowing it's going to solve your problem. Hope that helps. And this is a cool question. It is, how can my stator test good and seem to work fine when it's unplugged from the regulator? So I'm doing a typical stator test unplugged. But when I plug it in, I have no charging at the battery. So that's a great question. This is a situation, this is why I always say when I'm describing how to test the stator, not only do you test between all three leads of the stator, you always do a ground check. You always see if the stator coils are grounded, because you can very easily have a situation where the resistance between all three wires is good, meaning that all the coils are still intact and connected, but they could be grounded to the core at some spot. So what happens there is when you unplug the stator, and you're just measuring out here at the connector, you're going to get great voltage or resistance numbers. You're going to say, okay, stator's good. However, you didn't check to ground, and you would have found that you had a short to ground on one of the, well, all the wires would show it. You would show that you had a short to ground on the stator. So what happens is when you do this test, everything looks okay. You forget to check for grounding on the stator. Then you plug it back into your harness. So now it's connected to your regulator. So what you're not taking into account is your regulator. We have a positive and negative output of the regulator going to the battery. On just about every motorcycle ATV out there, your negative terminal of the battery is going to be connected to the frame. Okay. So what will happen if you don't check for that ground and make sure that your stator is not grounded, you're going to have a path to ground and you're going to lose all output from the voltage regulator. And I'll make a video sometime soon showing this on the test bench to illustrate it because it's very real. But always check for ground, because if you do have that ground there and you miss it, you're going to have the situation where everything tests good out here, but as soon as you connect stator to regulator, then you will suddenly have no battery charging. And that's due to the short to ground through the voltage regulator, through the battery, through the negative terminal to the frame, directly shorting out your stator. Okay, hope that helps. Always check for ground on your stator, not just a resistance or voltage test. We have a quick question today. How do I test a battery? Well, the quick check of a battery is always voltage. That gives you an idea, right? So you would just take your voltmeter, set it to DC volts. If it has a range, the 20 volt range, because you're trying to measure 12 volts or so. And at rest, your battery should be measuring about 12.5 volts if it's in good shape. If it's measuring any or much lower than that at rest, you probably have a problem with it. But if it measures 12.5 or so, especially if you just took it off the charger, charge it up first, take a good measurement. If it measures okay, probably all right, but that doesn't really tell you enough info. You can do some more testing. What really matters is a load test on the battery. You want to know that when you put it under a load, you're pulling current out of it, does it still hold its voltage up okay? A quick check, if you don't have a load testing tool, which if you have a lot of bikes or ATVs or something, buy it. You can get them on Amazon. We don't currently sell a load tester, but getting a load testing tool is a great idea because it'll let you put a load on the battery and then measure it and compare it to the cranking amp rating and give you a rating on the battery saying, okay, it's about 80% good or whatever. So I've got a couple of them. Personally, I use them. They're really excellent for doing it. It's the only way you can truly check a battery. But let's say you don't have one of those. We have a really nice voltmeter and charging system tester that is a voltmeter and then some lights to indicate good or bad. It's a great, cheap, quick, easy to use tool. And I'd recommend that for sure, but it does not load test. So a quick and dirty way of load testing on the vehicle when you don't have an actual tool to do it is use your starter motor. So put your voltmeter on the battery and measure it at rest. Let's say take it right off the charger so you know it's in the best shape it's going to be, okay? Measure your battery voltage. Let's say it's sitting there at 12.5 volts. Maybe have somebody do it for you. Hit the electric starter and crank the motor for a few seconds and let it start up. So you're going to see that voltage drop and dip when the starter engages because you're going to be pulling a bunch of current out of it. Typical drop, I don't know if there's a spec for this, but I would say 10 volts or 10 volts and higher is fine. You're going to see a couple volt drop at the battery when you are cranking the starter motor, but you should see it drop a reasonable amount, about 2 volts. And then as soon as it starts, you should see the voltage come right back up. Okay. So if you see your voltage, a 12 volt battery drop below 10 volts, I'm not going to say 1000% it's bad, but that's a pretty good indicator that it's got a cell that's not very healthy or something, and it's collapsing under that big load of the starter motor. So that's a reasonable rule of thumb for a quick check. I don't want to say 100% guarantee your battery's bad because of that, but if it drops below 10 volts and it was measuring good beforehand, you probably have a battery that's starting to fail or at least get fairly worn out. So cheap insurance, batteries aren't that expensive. It's a bike you rely on. Replace them every 2 years at the most. I mean, why not? Better than getting stuck when a battery fails. So, all right, hope that helps. The question today is, how can I test my charging system? So I'd really recommend watching. We have a YouTube video, a very full-length, long, detailed YouTube video showing this, testing a stator and a voltage regulator. I'd recommend that. For very much more detail, as these are short videos, but I'm going to go over it real quick with you because it's pretty easy. So typically, if your battery's not charging, you want to start by load testing your battery and make sure that it is in good shape. That's always number one. As long as your battery's fine, then we can look at the charging system. So typically, one of two components will fail that will stop charging the battery. Stator right here or voltage regulator. Stator, pretty easy to test. So especially, we're going to use the 3-wire stator here. And we have our connector right here with 3 wires in it, and we have a multimeter. Now, we're going to measure the resistance of these coils wrapped around the stator. The resistance of each coil is very low. Most meters are going to measure about 0.6, 0.7 ohms, somewhere around there. So make sure you have a meter that you can set to a low resistance range. Our RMSTATOR meters have a 200 ohm range at the lowest. Some meters are auto ranging and they'll just set for you as they take the measurement. But make sure you set your meter to the lowest range above what you're trying to measure. So we know we're going to measure less than 1 ohm. 200 ohms is the lowest. So fine, we'll set it right there. Okay. So let's start. To test a stator, we're going to measure resistance between all 3 coils. If we have 3 terminals here, 3 wires, we're going to measure between each pair of them. So 3 measurements. We can call them A, B, and C. So we're going to measure between A and B and C, and then C and A. So let's take those measurements. I'm going to put my meter into those terminals, and I get 0.8 on the first one. Then I'm going to go to B to C, 0.8, and then I'm going to go C to A, 0.8. So what we're looking for on a good stator is that all 3 of those measurements are the same. So they should all really, to be good, they should all be the same number, and they should be a reasonable number. Now, if I measured 0.5 here, I wouldn't worry about it. Most meters are not going to be super accurate down to this very low resistance range. So I'm really looking for a reasonable number, which is less than 1 ohm. And I'm looking for a match, the same number between all 3. So that tested good. The other test that's great to do is from any of the wires, because we already know they're all 3 connected together, and then a frame ground, or if you have the stator out of the vehicle, the metal core of the stator. And we're going to measure resistance there. Should say OL or 1 or whatever your meter says to indicate a open. So we do not want to short in any of the coils to the stator core. So if the stator was in the bike and I was measuring just out at the connector, I would measure between the connector terminal and then the frame of the motorcycle, or the engine mounting bolt, somewhere it's a good clean frame ground. Okay. So that's an easy way to test your stator resistance test. Okay. Other thing you can do is, if with the motor running, we'll set our meter to AC voltage. That's the V with a squiggly line over the top of it. And then we would start up our motor, and we're going to measure the voltage between all 3 pairs of these wires. And we're going to measure at idle, and then, or 1,000 RPM, and then at about 5,000 RPM, and see that we get good voltage numbers in both cases. A good rule of thumb, again, totally depends on your vehicle, but this is a pretty good rule, is at idle, 1,000 RPM, we're going to measure 10 to 15 volts AC between each pair. So obviously I don't have a motor running here, but I would do the same thing. I'm going to measure between each pair, and I'm going to see 12 volts right here. Okay. Then I'm going to go to the next pair and see 13 volts. Okay. And then next pair and see 15 volts. Okay. Totally fine. Again, the motor's sitting there running. It's idling at 1,000 RPM, but realistically that's up and down a little bit. We're never going to get the exact same number. So make sure it's reasonable and close, 10 to 15 volts. Then we're going to repeat the same test, holding the motor at about 5,000 RPM. The voltage should climb way up, typically 40 to 60 volts AC between each pair, and you would do the same test. Okay. And that's a good quick way to do a test on the motor. Again, that doesn't guarantee no problems at all, but it's a pretty sure thing that it's good. The other thing you can do is that ground test is measure voltage between any of the stator wires and the frame of the motorcycle. And if I didn't mention it, you would have the stator unplugged from the harness. I'm not sure if I said that. Okay, so that's a great way to test the stator. Let's get that out of the way. Now, voltage regulator. Only way we can reasonably test the function of the regulator is to test the rectifier. Okay, that's all we can really test with a multimeter. To do that, now again, I recommend watching the whole video with the chart because it'll break this down a lot further. I'm not going to go into super detail here, but I'm going to kind of explain the process. We have, if you watch our other video about regulators, we have typically 3 or 6 diodes, depends on the regulator, but we have diodes in here we can measure. Your meter will have a diode function that looks like a little arrow with a line at the end of it. So you want to set your meter to the diode function, okay? Now, the diode function is going to be showing you a voltage measurement, okay? Because what it's doing is pushing current from the battery in the meter through the 2 terminals, through your 2, leads on the meter, and it's going to push it through the diode. Now, if we measure the diode pushing current in the direction it should pass current, it should measure about 0.5, 0.6 volts. That's the voltage drop across the diode. When we reverse our leads and push current the opposite direction, the diode should block the current and should measure OL on the screen. So let's illustrate that. Now, the easiest way to do it is follow our troubleshooting chart, because it just gives you a chart that says meter red to battery positive terminal, meter black to stator terminal. So it's easiest to follow a chart, but I'm going to run through the test really quick. So I'm going to start with meter red to battery positive, and then I'm going to check the 3 terminals of the stator. All 3 say OL. That's correct. They should. Now we're going to reverse our leads. So we're going to push current the other direction. So I'm going to have meter black, meter negative to the battery plus. And now I'm going to touch all of these. I should measure. What am I getting there? Hard to read on the meter. Sorry. Okay, so that's measuring 0.184. So I should have mentioned this is a MOSFET type. So it's going to, one set of diodes, which is actually a transistor, is going to measure about 0.1 instead of 0.5, like I said earlier. So I'm getting 0.186 on each of those. Perfect. So I got an OL in one direction, a 0.1 on the other direction. Those diodes test good. Now we're going to go to battery negative terminal. I'm going to start with meter red to battery negative terminal. I'm going to test all 3 of these. These are the diodes. I should measure about 0.5 volts, and I do. You can see right there, 0.512, 0.510, 0.505. Great. They're all dropping voltage correctly across them. Now I'm going to swap my meter leads, meter black to battery negative, and then meter red to stator terminals, and I should get an OL on all of them, and I do. Okay, so that is how we would test the diodes or the transistors in a MOSFET type in same process. That's how we would test the regulator to get an answer if the rectifier is functioning. If those check out, the rectifier part's working okay, and typically this is not going to be at fault. However, a regulator can pass that test and then fail in such a way that it overcharges. And that will mean that you would measure at the battery that the voltage, as you rev your motor up, RPM climbs to 5,000 or so, you're going to see the battery voltage just keep spiking. It'll hit 17, 18 volts. If that's happening, the rectifier's working, but the regulation part is not functional. So it would still need to be replaced. Okay, hope that helps. That's a quick overview on testing your charging system, and I hope you can get your bike fixed up using that info. And the question is, do you have any troubleshooting or testing guides available? And the answer is yes, we have a great one. On our website, down at the bottom, there's a testing diagnostics link. Hit that, you will see a PDF file you can download or print or whatever you want. It has all of our testing guides for stator, regulator, pickup coil, ignition coil, you name it. It's all in there, and it's super helpful. Also, check out our YouTube channel. We have lots of how do parts work and how to test them videos that are really in-depth, and they really explain well how to test these parts. So check out all that stuff we have available. It's on our website or our YouTube channel. So check it out, and then you can always contact our customer service team if you have further questions. Thanks a lot.